Good evening, my name is Chin Wen King. This presentation is for the CA project for my knowledge engineering course, and my name is Chin Wen King. You can look at the top right hand corner here, and this is my email address in case you want to contact me. And a brief introduction: I've been working for more than 20 years. My current job as a IT manager in Samsung SDS AP. I've been in that company for 7 years. And academically, I've got my honors from UNISIM 3 years ago in enterprise resource planning. So let's go into the Sudoku problem. I created a program to solve Sudoku. So if I generate random value and then I try to solve it, so it will try to find a solution using DFS or a while loop. So if we look at the code, how it is done, a DFS code is very short. So first we loop through from 0 to 81. If we reach 81, it means it already find the solution and you will just return successful. And then if it not 81, then actually there is a for loop from 1 to 9, the value pass into the child, this part, and ask the child, is it resolved? And this is recursively calling until the end to determine is it resolved. So in case it's resolved, it means it finds a solution and then it will stop. And if not, it will reach this here and then you will just set that value back to 0, go back to the parent, say it's false, and then the parent will same thing, have a for loop, and you will go to the next number, and this repeats until it solves the problem. So the other way of solving is using a while loop. Performance wise, it's almost the same timing. 1 minute, this is 1 second. If I solve DFS, also around 1 second. So performance is not a big difference, but the code is a lot longer. This part, all the way to this part. And the good thing about the while loop is it will not go out of memory. But the DFS, although the code is very short, but if the problem is if the depth is very deep, for Sudoku case it will not happen, but if in real case the depth is very deep, actually it will cause out of stack memory problems. And the code, it is very short and the logic is in the is valid. We just check the row to make sure there's no duplicates, and then we check the column to make sure there's no duplicates, and then check the 3 by 3 squares to make sure that there's no duplicates. That's the is valid logic. So Sudoku solving, business wise, I don't have an example how it can be applied, but academically, I've learned about decision tree, and I know that actually to solve the decision tree, actually we can use DFS logic, recursively trying to determine the values at each leaf node. So actually academically it can be applied in any situation that the collection is a tree structure and we need to traverse each of them. So with that, that's the end of my presentation. Thank you very much for your attention. Good night.